Hello, everyone. So recently, some of the most compelling deepfake videos of actor Tom Cruise were published on TikTok. And beyond the excellent face swap synthesis, these videos also benefited from a talented performer who resembled Tom Cruise and is capable of imitating his mannerism and voice. The impersonator, however, left behind an important biometric cue to his identity. That is, his ears were different from Tom Cruise's ears. So today we are going to discuss how we can use human ears to detect deepfakes. We are going to exploit both dynamic motion features and static appearance-based features of human ears to detect deepfakes. Dynamically, we'll exploit that movement of the mandible, that is lower jaw, causes the changes in the shape of the ear, and that is causes motion in the ear. For example, we can see the motion in the ear with motion of the mouth in the left image. In a lip sync deepfake, where the manipulation of the mouth happens separately from the rest of the head, the dynamics of the ear motion will be decoupled from the mouth and jaw motion. Statically, the shape of the human ear has been shown to provide biometric signal, while the facial identity of Tom Cruise in the face of deepfake is correct. The ear belongs to impersonator's ears, which is different from the Tom Cruise ears. So for dynamic features, we tracked ears in the video and divided that ear into three broad regions, which we call from top to bottom as helix region, tragus region, and lobule region. Finally, the average motion in the horizontal and in the vertical direction in these three regions give us a total of 6 motion features from the ear. These 6 motion features from the ear were correlated with lip vertical distance and the root mean square energy of the audio, yielding a total of 12 correlation-based features from a 10-second video clip. We compute these correlation features from 10-second video clips of 4 individuals, that is Donald Trump, Joe Biden, Angela Merkel, and Mark Zuckerberg. Shown here are the distributions of correlation between the horizontal motion in the 3 regions of ear and the vertical distance between the lips. The white line in each graph corresponds to 0 correlation. And in each case, we found that on an average, the correlation between the lips and the ear were non-zero. These correlation distributions were found to be somewhat identity independent, but also they exhibit some identity-specific properties. We also simulated lip sync deepfakes by simply correlating the ear movement from one video segment to the lip movement of a randomly selected segment of the same length, where the correlation was found to be mostly 0. We trained a linear binary classifier using the 12 features, the 12 correlation-based features from videos of 4 individuals and the simulated lip sync deepfakes. And they shown here are the accuracy of that classifier in terms of AUC on the training dataset, on testing dataset of simulated fakes, on lip sync deepfakes that we created using state-of-the-art lip sync synthesis method, and in the wild lip sync deepfakes that were downloaded from the internet. We obtained on an average an AUC of 0.84 on the testing dataset. For ear biometric, we want to exploit the difference in the shape and structure of ears of the impersonator and that of the Tom Cruise. So for this, we collected 13 images of actor Tom Cruise from various internet sources where the ear of Tom Cruise was visible. We use one real image as the reference ear, and the shape of the ear is represented by 2 Bezier curves, which are shown in yellow on the reference on top left. The shape of the reference ear is compared to the images of Tom Cruise ears and impersonator's ear. Shown on the top right are the example of real Tom Cruise ears, where the shape of the reference ear in yellow closely aligns with the shape of the ears in the image given in the pink. Whereas in the bottom right, there is a difference in the shape in yellow and pink curves of impersonator ear and the reference ears. So thank you for listening. And for more details, please refer to our paper.